This video is designed to introduce you into a training methodology known as the HIFT methodology. HIFT stands for High Intensity Functional Training Methodology. And we're going to talk a lot about why this methodology seems to work. There's an abundance of research out there that is now showing the positive benefits of training in this method and how everyone from young athletic individuals to older non-athletic individuals can take advantage of this methodology of training. So the three components behind this ultimately started in the sport of CrossFit. Now, this video is not meant to be an endorsement of the CrossFit product, corporation, or organization, but it's simply meant to talk through their theories and methods of training, which I think hold a lot of validity in the exercise training world. So there are three primary components, and this includes functional movements, high intensity, and constantly varied exercises. So we're going to talk about each of these three components separately. The first is this idea of a functional movement. Now, a functional movement is something that we consider to be natural. The body will naturally move in this pattern, also known as a universal motor recruitment pattern, or things that we do in daily living. Things such as squatting is a typical functional movement, getting in and out of a chair. For those of you that have ever squatted down into a toilet, well, you're moving into that squat position and then you're standing out of it. And oftentimes, our hips are going below our knees in that squatting maneuver. And so this is truly an activity of daily living. Functional movements are safe. And what I mean by that is we can test functionality by applying a simple rule to it. If it doesn't look normal without the weight, it's not functional. Okay? Squatting down and standing up looks like a normal everyday movement that we would do in sport and activity. However, a leg press in the alternative, or a hamstring curl, without that weight machine attached to it, it does not look normal. And so I would say that those are not functional activities, but the squat is. Functional movements are compound and yet irreversible, meaning they have to be done all together and they cannot be broken apart. Let's take a minute to look a little bit further at this idea of compound yet irreversible. Take, for example, if I give you three things on this piece of paper. There's one, there's two, and there's three. Take these three lines that I have given you and put them together to form a letter of the alphabet. Give yourself a second and think about what letter I just wrote on the board here. So, if you came up with the fact that I wrote the letter A, then you're right. However, most people probably interpreted this as something different. Some of you may have in fact said, well, that's an easy one. You wrote the letter H. Or maybe they said, that's clearly you wrote the letter N with those. Or you wrote the letter Z. Now, all of these answers could have come from these three components that I just wrote for you over here. However, there's only one correct answer that I was thinking of. So this is what I mean by the fact that functional movements are compound yet irreversible. The letter A, as seen here, all together cannot be broken into its individual parts here and still be recognized. The same is true for a functional movement. We can't break it apart and yet still recognize that that's a functional movement. Let's go back to our squat example. If we have an individual who is going into a squat position, this is your hips over here, these are your knees, and these are your feet. We know that when we squat, the hips move into a flex position, the knees move into a flex position, and the ankles move into this dorsiflexed position. Now, if we were just to have this same person stand straight up and down, the hips are here, the knees are here, and we have them dorsiflex their feet, well, all we're doing is this one component of the squat, but they don't look the same. And so the squat maneuver itself cannot be broken down into individual pieces and still recognized. So we can say that functional movements are compound yet irreversible because of this principle. Functional movements also adhere to this principle of a force developed at the core transferred to the extremity. Let's see how this works in practice. So when we talk about the core, we talk about the hips, the spinal column, all the way up through the shoulders. So if we were to diagram this in a simple drawing, we would focus on our hips or pelvis as a unit, and from there, we would accentuate the spinal column with our lumbar curve and our thoracic up to our cervical. Our head is at the top of this chain, and then coming off of our hips are going to be our femurs, followed by our knees, and then our tibia and fibula down into our ankle. So what we're talking about from core to extremity is the fact that this core section is right here. It's from the shoulders, it includes the pelvis, all the way up to the spinal column. So this section here has to be wetted. What we don't want to have happen is we don't want our vertebrae moving separately from our hips. So when we generate a force in this area, the hips, the vertebrae, and the shoulders, they are then transferred outward towards our extremities. So any force in here gets generated through the legs and into the ground. So things like jumping would mean that our core is wed and the force is actually produced from our legs. Same thing if we were to go ahead and talk about what's happening with our arms. Imagine your shoulders are coming off here into your hands. The same process would happen in something such as throwing. The force generation would start with the wetting of the core, and then it would transfer outward to the extremity. So jumping, kicking, squatting, throwing, all of these are examples of a force being generated at the core and then transferred out to the extremities. So this core to extremity principle, keeping the torso wed to the pelvis and then distributing the power from the core to the extremities, involves developing a high force with low velocity at the core and then translating that to a high velocity, low force at the extremity. Let's go back to our example of throwing a baseball. When we generate that high force at the core, what this allows us to do is transfer that force to the ends of the fingers where they hold the baseball and create a huge velocity. Hence why the human body can throw over 100 miles per hour if it's well trained enough. So our functional movements are innate, natural, essential to activities of daily living. As such, they are safe things that we can do, compound and irreversible, and adhere to a principle of transferring force from the core to the extremities. So what does high intensity mean? Well, in order to talk about high intensity, we have to review what the goal of all of our sport and exercise training is. Whenever we're on a field of competition, our desire is to outwork the opponent and be more powerful than them. If we're working in the gym setting, What we want to do is outwork our former selves and develop our power over time. So both of these pertain to this theory of high intensity. Keep these goals in mind as we move through this process. We train to increase our ability to do work. Do work, son, right? So work, essentially, if we go back and look at the true definition of how we calculate work, those of you that have taken physics should recognize this, that work involves force times distance. So moving a body or a mass, developing force, and moving that a distance works. Okay. Take, for example, the deadlift. Lifting a barbell of a weight, let's say 135 pounds, and we're going to deadlift that weight up to our waist. Say you have a 32-inch inseam. So now we know we're going to deadlift 135 pounds and it's going to travel 32 inches. So we can calculate the work done. Now, somebody who is taller, who has a 40-inch inseam, is actually going to do more work. 135 pounds times a distance of 40 is greater than our previous example of 135 pounds over a 32-inch distance. So people could do more work than others simply by increasing the distance, or how we typically see this, increasing the weight on the bar. This is why individuals who are shorter or who have a shorter wingspan find it easier to do things like a squat or a bench press. It's essentially because they have a shorter distance to move that. So our goal about work is moving a large load a long distance. Now, this really doesn't work out in sports so well. Think about running a 5K race. What you're going to do is you're going to take that large load, which is your body weight, and you're going to carry it over a long distance, which in this case is 3.1 miles. So we know force times distance. But this doesn't tell us who wins. What do we need to consider to identify who wins the 5K? Well, that's going to be the person that does that the fastest. So we have to add another component to our definition. What we want to do is ultimately move a large load a long distance, and we want to do that quickly. And so now we're going to measure quickness in time. This is our second goal of sport. We train to increase our ability to generate power. Power can be defined using work. We just define that. Work over time is the definition of power. And since we know that work equals force times distance, we can take this formula and break it down and say that force times distance over time. So let's go back to our deadlift conversation. Moving 135 pounds, 32 inches over time. So how fast can we move that barbell up and down? Someone who has greater power is going to be able to move that barbell faster. So it will take you less time to lift the barbell from the ground up to your waist. Somebody who generates less power, it's going to take them a longer time to lift 135 pounds the same distance. So now we see three variables that can be manipulated in order to generate more power. But ultimately, in sport, we are charged with moving a large load a long distance and doing so quickly. So power. If average power, we have decided, is measured as force times distance over time, or work over time, we can put in units and start to see how this works out. So force in pounds times distance in feet. And what we're going to do is take our weightlifting example and add how many times they're going to do that. So ultimately, if we lift that barbell 10 times 32 inches, right, that's 320 inches that we have then moved it up and down. So pounds times feet times repetitions. And then how long does this take? And we can look at that in either minutes or seconds, some value of time. So if we rearrange these, foot times pounds divided by minutes, this actually gives us a value called horsepower. Now you may be thinking, where else do we see horsepower in all of this? Well, that's how we define how much power an engine in an automobile can generate. The more horsepower you are generating, the faster you will go, the more powerful your vehicle will go. Keep in mind that if you are doing an air squat, just a plain body weight air squat up and down, you can generate 1 horsepower with each repetition. That's a lot of power that the body is capable of delivering. We also want to identify that the average power is equivalent to the intensity of movement. The faster we move, the more intense the activity gets. The more weight we move, the more intense the activity gets. The further we move, the more intense the activity gets. So we can do this a number of different ways. Move more weight, move the weight that we have further, or move the weight that we have faster. All of these will involve increasing the power and thereby increasing the intensity of activity. So what we arrive at here through our discussion about work and power is the fact that power is a direct measure of intensity. And because of this, exercise intensity is what's going to give us the best results. The athlete that can perform with the highest intensity over the entire athletic event is going to have the best results. And so what we come down to is this statement that intensity is the independent variable most commonly associated with maximizing favorable adaptation to exercise. Put this down. Intensity is that variable that is related to maximizing adaptation to exercise. If your athletes aren't training with intensity, they will not maximize the adaptation to exercise. They're not getting the most benefit for their training sessions. This is why coaches push their athletes as they do in practice sessions and in the weight room. Because if you're just going in and going through the motions, you are not maximizing your time spent there. Now, intensity also has to be considered that it is relative. It has not only these physical attributes that we're talking about, but there are psychologic attributes as well. What is intense to one individual is not to another. So we're talking specifically here about the physical attributes of intensity. Constant variation. Let's talk about constant variation and where this comes from. We start off understanding that constant variation has to do with the Hopper model of fitness. And we'll remind you that that stands for being prepared for the unknown and the unknowable. Whatever life is going to throw at you, you will be physically ready to handle it. Constant variation also means that our training programs must be broad, inclusive, and general. Broad in that they touch a number of modes and components. They touch a number of time frames and a number of intensities. They are inclusive. We don't leave any of the 10 physical components of fitness out, and yet they remain general enough that we can have carryover from one exercise to another. This leads us to the idea that a constantly varied program is also a generally physically prepared program. This means that your athletes should be generally physically prepared for everything that they may do. Keep in mind that a GPP program is opposed to specificity training. In specificity training, we are targeting a specific movement, action, sport, or position. A GPP program, alternatively, targets improvements in overall fitness, the 10 general fitness skills, over all 3 metabolic pathways. And so This type of training is ideally developed for the off season, for preparation for your sport, when we can spend the most time going after all of these inclusive and general fitness categories. Now, what is meant by constant variation is the fact that you are only as good as you train. And so what ends up happening is your failure will come at the borders of your training experience. Let's take a little look at this more in depth. So when we talk about training, we can say that you are only as good as your training and you're going to fail at the borders of your training. And so if we were to go ahead and diagram everyone's fitness, it would look something like this. And in this circle would be all of the items that you have trained for, right? The athlete that trains short distance. Maybe they train 100-meter sprints. They train deadlifts at 100 pounds. They train vertical jump, all these short explosive activities. Maybe they sometimes train a 200. Well, the problem comes with all of a sudden when this person who trains at these short, high-intensity, powerful type activities has to run 400 meters instead of 1 or 200, what we do is we challenge them to run 4, and that becomes outside of their target area. And so we're going to fail at anything that is outside of this border. So what does that athlete do? Well, they're going to go ahead and they're going to actually change their training routine so that now we get a little bit bigger and we train so that we can accomplish that 400 meters. It's now within our training cycle. But now, maybe all of a sudden we're faced with another challenge where we have to run the mile. And so then that becomes way outside of our 100, 200 meter, 400 meter. Now it's 4 times around that track. And so again, what we have to do is this athlete is going to have to expand their performance in order to include things that are outside of it. So that's what we talk about when we talk about training and failing at your borders. You have to be general enough so that your fitness wheel gets as big as possible to include all of the potential tasks that you may be faced with. So remember, be prepared for the unknown and unknowable in the off season when you are ready for a generally physically prepared program, because you are going to only be as good as the exercises that you do, and you're going to fail at the borders of your experience. So for true fitness, we want to make sure that our athletes are prepared across the spectrum of possible physical challenges. So in conclusion, this idea of training involves constantly varied functional movements performed at a high intensity. And remember that intensity is the independent variable most commonly associated with maximizing favorable adaptations to exercise.